Hey, this is Mr. Lineski here with Unit 4, Section 1. We're looking at classifying triangles and different triangle properties. Unit 4 is all about triangles, Unit 5 is all about triangles, and we're going to talk about triangles for quite some time in this class. So as a reminder for all of you out there in YouTube geometry land that the best angle from which to approach any problem is going to be the triangle. The triangle. Let's get started. Alright, so we are looking at some vocabulary here. Different ways to classify triangles. There are two ways to do that. There are classifying by the angles or classifying by the sides. So we're going to look at the names that we can call a triangle based off of its angles. An acute triangle is whenever a triangle where all three angles are less than 90 degrees. An obtuse triangle is when one angle in the triangle is greater than 90 degrees, so that might look something like this. Remember, obtuse angle means bigger than 90. A right triangle, we've heard that before, is just any triangle that has a 90-degree angle in it. Equiangular is whenever all three angles are equal to each other. And any time that that happens, the angle measurement is going to be 60 degrees. We'll talk more about that in a moment. Just as a reminder, these little marks here indicate, hey, all three angles equal each other. Another way to classify triangles is by its sides. And so sides, we have three names. The first name is equilateral. That just means that all of the sides are congruent or the same measurement. And so we can mark that like this. Isosceles triangle is when at least two sides are congruent, and so that might look something like, I don't know, this. We can say those are congruent. And then scalene is whenever none of the sides of the triangles are equal, and so we could maybe have something like that. And so those are the different ways we can classify. Typically when you classify a triangle, you give it two names, like you can say something like an acute isosceles triangle, or a right isosceles, or obtuse scalene triangle. So they kind of have two names that go with it. So some properties that go along with those triangles is that in any triangle there can only ever be at most one obtuse or one right angle in a triangle. Again, we'll talk more about that in a moment. A triangle is going to be equiangular if and only if it is equilateral. Hey, if and only if, biconditional. So remember, that means it works backwards. Meaning if I tell you something's equilateral, you can say it's equiangular. If two angles of a triangle are congruent, then two sides of the triangle must also be congruent. And that kind of relates to an isosceles triangle. We'll talk about that in a moment. And then finally, that all three sides of a triangle are different if and only if all three angles are different. So, talked briefly about isosceles triangles. Isosceles triangles has a property called the base angles theorem, which states if two sides of a triangle are congruent, then the angles opposite them are also going to be congruent. This is known as the base angles theorem, and so this works in an isosceles triangle because we're saying two sides of a triangle are congruent. And so in any triangle, if I have two sides that are congruent, let's just say these two sides were congruent here. So those are my congruent sides. This is an isosceles triangle. It says then the angles opposite them are congruent. So if this is my congruent side, just imagine that you were sort of drawing a line to the angle that's opposite that. So this angle here and this angle here. So these are the two angles that are opposite those sides. So these two sides would be congruent and these two angles would be congruent. Now I don't mean that all four of them are the same, because sides and angles have different measurements. Angles are always measured in degrees. Sides are measured in things like inches, feet, centimeters, etc. So like this could equal 10, this could equal 10, but this might be like 65 degrees, and this could be 65 degrees. Okay, there is a converse to the base angles theorem. Remember, converse just means we switch the if and the then. So if two angles of a triangle are congruent, then the sides opposite them are congruent. So that basically means it could go like this, and I could say this and this. Now notice I'm calling them base angles, but when we hear the phrase base, we always think of the bottom. And I specifically did both of these examples so that the base angles are not on the bottom. base angles don't always have to be on the bottom. So like this would be the side opposite that. So I could say that's congruent. This would be the side opposite this angle, and those sides would be congruent. And so that's your converse of base angles theorem. Basically, if the angles are congruent, the sides opposite them are congruent. So let's actually apply that to a problem. It says find the measure of the sides of isosceles triangle KLM with angle K congruent to angle L. So angle K and angle L, those are my base angles. Again, notice they're not on the bottom. Just because it says base doesn't mean it's on the bottom. And so that means the sides opposite these are equal. So I have this, and I have this. Notice I'm not going to do anything with d plus 6. And so to solve this, we're simply just going to set those two things equal to each other. The nice thing about geometry is most of the times we're setting things equal, or we are adding things and setting them equal to 180. And so when I add d and add 13 to both sides, that gives me 5d equals 25. Divide by 5, we get d equals 5. Now the problem does want us to find the measure of the side, so we have to go ahead and substitute 5 back in. So when I substitute 5 into here, 12 minus 5 is equal to 7. Because I'm saying these two things are equal, I really shouldn't have to substitute into this. But if you want to just double check yourself, it should be the same. 4 times 5 is 20. 20 minus 13 is 7. And then over here, 5 plus 6 is equal to 11. Alright, so moving on to the next problem. It says find x and the measure of each side of equilateral triangle ABC. So the issue here is that I don't have a triangle anywhere, so how do I know what this looks like? Draw one. Just draw any triangle and then label it however you want. A, B, C. But Mr. Lineski, I wanted to put the A at the top. Okay, virtual student that I don't know, go ahead and put the A at the top. That's fine. You could have said A, B, C. Works for me. So now we just need to fill in these random sides here. So AB is 6x minus 8, so 6x minus 8 goes here. BC is equal to 7 plus x. That goes here. And AC is equal to 13 minus x. So that goes there. The nice thing about equilateral is we know that these three sides are all equal to each other. Now, do I use all three things in an equation? No, I only need two things. Which two things can I use, Mr. Lineski? Great question. You can use any two you want. So let's say I wanted to use this one and this one. So now when I go to solve for x, I would add x to both sides, subtract 7 from both sides. That gives me 2x equals 6, and therefore x equals 3. That's one way of doing it. Maybe instead you wanted to use this, and I don't know, let's say this and this. So you can say 6x minus 8 is equal to 7 plus x. And so I can add 8 to both sides and subtract 7 from both sides. That gives me 5x equals 15. Divide both sides by 5 and I get x equals 3. Hey, that's the same answer. It works either way. Math is fantastic. But remember, we need to figure out what's the measure of each side, so we need to substitute that 3 back into the equation. Again, the nice thing is we really only need to do it once, because once we solve for one of these, we have solved for all 3 of them. So I'm going to do this one because it's the easiest. 7 plus 3 is equal to 10. Therefore, all 3 sides should equal 10. Alright, moving along. We now are looking at something called the triangle angle sum theorem. There is a little typo here. It says the sum of the measure of the angles of any, should just be triangle, not plural. So the sum of the measure of any triangle is always going to be 180 degrees. So anytime I have a triangle, regardless of what type it is, going back to this, doesn't matter if it's acute, obtuse, right, or equiangular, all 3 angles always add up to 180 degrees. That's just a fact of life. And so now we're going to use that to help calculate the following situation. So we're given sort of 2 triangles here, and we're asked to solve for angle 1, 2, and 3. So looking at this triangle here, To solve for angle 1, I know there's 180 degrees in any triangle, so I'm going to do 180 minus 38 minus 67. And so when I subtract all that, I get that angle 1 is equal to 75 degrees. So now I can use this and this as vertical angles. Remember in Unit 1 when I said vertical angle is like one of the most important things in geometry? It's because we see it quite a bit. Same with linear pairs. So vertical angles are congruent. So if 1 is 75, 2 is 75. And now to solve for 3, now we look at this triangle and we would say, oh, there's another triangle that equals 180. And so we just subtract all of that. And when we subtract that information, we get that angle 3 is equal to 57 degrees. There's a corollary that kind of falls from this theorem, and that says the acute angles of a right triangle are, and the answer for that is complementary. So if you think about what that's saying, it's saying in a right triangle, so I know I have 90 degrees here, it's saying that these two angles here, the acute angles, because they have to be less than 90, these will add up to equal 90 degrees. And if you think about that, an entire triangle is 180. And so if I said, well, what's 180 minus this 90? I'm left over with 90 degrees to split up amongst these two things in any way that I want. I could say that this is 1 degree and that's 89 degrees. I could say that this is 50 and that's 40. But these two angles should always add up to 90 in a right triangle. There's one last little theorem that we will talk about, and then I'm done talking for today. The measure of the exterior angle of a triangle is the sum of the measures of the two remote interior angles. So on this figure here, what that looks like as an equation is the measure of angle 1 is equal to the measure of angle B plus the measure of angle A. In other words, you're saying angle 1 is equal to these two angles. And I'm going to give you a quick example that involves numbers to kind of help you out with this. So let's say that this equaled 100 degrees. I know for a fact by a linear pair that this angle here has to equal 80 degrees. Because linear pairs add up to equal 180. And so now, let's pretend that this wasn't there. So I'm still going to remind us that that angle is 100 degrees. What the exterior angle theorem is saying is that this exterior angle is going to equal the sum of these two angles. And so remember, if there's 180 degrees inside a triangle, and I already have 80 degrees there, when I subtract 100 out, or I'm sorry, not 100, when I subtract 80 out, sorry about that, when I subtract this 80 away, what am I left with between these two angles? I'm left with 100 degrees. And that 100 degrees is the same thing as my exterior angle. So that's kind of how that theorem works. So looking at our little example problem here, we have a piece of fabric in the shape of a right triangle. It says find the measure of angle ACD. And so here's our exterior angle. And we know that the exterior angle is equal to the sum of the remote interior. When it says the remote interior, it means the one that doesn't form a linear pair with this. Because I can't really do anything with the linear pair because I don't know what x is. And so to set this up and solve, we just say 3x plus 10 is equal to x plus 90. Remember, just because the number 90 is not written there doesn't mean that that angle doesn't exist. That box just means 90 degrees. And so now we simplify and solve for this. So subtract x, we get 2x. Subtract the 10, we get 80. Divide by 2, we get x equals 40. Remember, though, we do need to solve for measure angle ACD, which is this right here. So 3 times 40 plus 10 gives me 120 plus 10, which gives me 130 degrees. Alright, that is all of our vocabulary and theorems all about triangles. Remember, a triangle always adds up. The angles of a triangle add up to equal 180 degrees. One little factoid I want to point out is that, because this always gets confusing, the sides sides of a triangle do not equal 180 degrees. The angles do equal 180 degrees. That's a really big important part. Alrighty, so that's it on triangles. Thank you for watching. I know it, and now you all know it.